Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. In this video, we're going to solve the homogeneous first order differential equation dy by dx is equal to y³ plus x³ divided by xy² plus yx². To find out how to identify homogeneous differential equations and the necessary substitutions required for a solution, then please see this video. Our first step in solving this differential equation is to replace all the x's and y's with the ratio of y over x, and to replace dy by dx with v plus xdv dx. To get the right hand side of the equation into the necessary form, we need to divide each term by x³. So we have dy by dx is equal to y³ divided by x³ divided by x³, and that's all divided by xy² divided by x³ plus yx² divided by x³. And simplifying this, we have dy by dx is equal to y over x cubed plus 1 all divided by y over x squared plus y over x. So now we have the right hand side of the equation in the form where we can replace all the ratios of y over x with v, and we can replace dy by dx with v plus x dv dx. And after making this substitution, we have v plus x dv dx is equal to v³ plus 1 divided by v² plus v. And subtracting v from both sides of the equation leaves x dv dx equals v³ plus 1 divided by v² plus v minus v. And simplifying this, we have x dv dx is equal to 1 minus v multiplied by 1 plus v, all divided by v into the bracket of v plus 1. And v plus 1 in the denominator and the numerator are eliminated to give x dv dx equals 1 minus v divided by v. And we can now separate the variables to leave two integrals. On the left hand side of the equation, we have the integral of v divided by 1 minus v dv, and on the right hand side of the equation we have the integral of 1 over x dx. So starting with the left hand side of the equation, we need to evaluate the integral v divided by 1 minus v dv. To do this, we need to make another substitution. So we'll let u equal 1 minus v, and du dv is equal to minus 1. So dv is equal to minus du. So making this substitution for v, we have minus 1 multiplied by the integral of 1 minus u divided by u du. We can split this into two integrals. So we have the integral of du minus the integral of 1 over u du. And evaluating these, we get u minus the log of the absolute value of u. Substituting back in for u, we get 1 minus v minus the log of the absolute value of 1 minus v. And so the integral on the left hand side of the equation evaluates to 1 minus v minus the log of the absolute value of 1 minus v. And on the right hand side of the equation, the integral evaluates to the log of the absolute value of x. And we need to add a constant of integration, so let's call that c1. If we now resubstitute for v, where v is equal to y divided by x, we get 1 minus y divided by x minus the log of the absolute value of x minus y over x is equal to the log of the absolute value of x plus constant c1. Now we can simplify negative log of the absolute value of x minus y divided by x to be the positive log of the absolute value of x divided by x minus y. And simplifying this further, the log of the absolute value of x divided by x minus y is the same as the log of the absolute value of x minus the log of the absolute value of x minus y. And if we subtract the log of the absolute value of x from both sides of the equation, we're left with 1 minus y divided by x minus the log of the absolute value of x minus y is equal to constant c1. If we now let a new constant c2 equal 1 minus c1, our equation simplifies to the log of the absolute value of x minus y plus y over x is equal to c2. And exponentiating both sides of this equation gives e to the power of the log of the absolute value of x minus y plus y over x is equal to e to the power of constant c2. And this simplifies to e to the power of the log of the absolute value of x minus y multiplied by e to the power of y over x, which equals e to the power of constant c2. This simplifies to give us our final solution of e to the power of y over x multiplied by x minus y in brackets equals constant c, where c can be positive or negative.